We now have an error window that we can show, but we don't actually handle the crashing of the application correctly yet. At the moment, if we crash, we get to the exception, but we can't re-show any Avalonia UI because the application thread's already wound up. So the goal of this now is to figure out a way to accurately re-show an error message when the application crashes. So if we were to go to Actions at the minute and cause a crash, you can see we throw the exception, but when it bubbles up to the application, or in the program rather, we try to do this and this obviously doesn't work. So this is what we need to fix. Because we might as well start making this into a proper crash handler kind of system or service, let's just do it properly from the start. So we'll add a new folder. I'll just call this crash for now. And then in here, let's make a data model. So something to store the crash data. So we'll just call this literally crash data. Again, don't overthink it. We can always rename these and change them as we go forward. And now let's think about things we need in the crash data. So we'll want to know the time of the crash. So we'll do a date time offset, so we're not dealing with differences in zones. We'll just call this crash date. Then we'll have a source, so some kind of source of where the crash come from. And this can either be set manually or we auto-detect it. It depends what we want to do. We'll then have the title, I guess. Well, we don't really want to call it title. We're using that in the view model, but in terms of a crash, we'll just call it a short message. And then a long message would be the stack trace. So let's call that one the stack trace because that's what we will do. And this will just be like a short error message. Or you could even call that error message, to be honest. So error message, stack trace, source. That'll do for now. If we need anything else, we'll come back to that. Now, the way I'm thinking we handle this crash is I've taken a quick look at how this is all put together and built up. And to be honest, by the time you've unwound here, trying to respin up an Avalonia inside of this thread after it's been used once is a lot more work than I think we just spin up our application again. So I think we just let the application die and spin it back up. So to just test that first, what we do is try and get the application to crash and just restart. We need to put protections in place that we don't just instantly crash, restart over and over. But ignoring that for now, let's just try to get the application to spin up. And then what we can do is when we do crash, we could use this crash data, write, say, a JSON file somewhere. And then when the application restarts, somewhere in, say, I don't know, the main view model or something, somewhere where the application simply spins up, we'd have some code somewhere in here that says, right, let's look out for a previously written crash file. And if it is, display the error then. And what would happen then is we'd bubble up to here, we'd crash, we'd write a JSON file here with the crash, tell it to restart the application. When it restarts, the main view model then kicks in, looks for that file, and then displays the error message and deletes the file so that if it crashes again, or if it simply restarts, it doesn't display the old error message. That's my train of thought. So restarting an application is pretty simple. We can do this in one line. You do it so many times that you'll know this off by heart. You can just do, and this is Windows specific, by the way, or desktop specific. That's why we're in the program of the desktop app, and that's all we care about for now. So we'll do process.start, and then we just need to get the type of this program, and then the assembly location is automatically detected for us. And then that's it. We should spin up the application. You don't need any other handlers. That should just all work for us. And then just a catch that we will ignore because we basically don't care if it fails. Remove that extra bracket. And then let's just catch here and check that we've got the right exe. If we go to actions and cause a crash, bubbles up, gets to here, and close, that's a DLL. So the assembly is the DLL, and obviously we want the exe. And in our case, we can always assume that the name of the program's DLL is going to match and it's just going to have an exe. So we'll just replace .dll with .exe. And then let's try that again. And we should, to be honest, be able to just uncomment that. We know that's now going to have an exe at the end. And it should crash. It will break us out of the debugger and then restart a process without debugging. So we should see this close and then obviously the application restart. So that's going to crash. You can see this is still running and the application's restarted. So I don't know whether the debugger's magically managed to reattach or whether we're hanging and we need to fix that. So let's crash again and see if we hit debugger. No, so we don't hit the debugger and it restarts. But we have an issue where, oh no, I think that's just the debugger trying to be smart. So we'd lost debugging, but it didn't close the debugger until we closed the window. So it must look for an active window with that name. So it did actually stop the process. So that's part of what we wanted. We now have the auto restarting. So what we need to do here then is now write an error log or write a crash log. And I think instead of just writing it here, we're going to make a service or basically a provider. So inside of crash here, let's add a new class. And the thing is, we have services here. So even though we've got the crash data here, we probably want to put the service here, to be honest. A class to here, and we'll call it crash service. And this one's going to be a bit unique because instead of injecting it, because we want to use it at this point where there's no dependency injection, there's nothing else, the crash needs to be accessible everywhere in the application. We're going to make this static. Now, you tend to avoid static absolutely everywhere you can because you can't kind of swap and replace them in applications. You can't unit test them easily. It's not something you normally do. But in this case, just for a simple crash service that's going to write errors and read errors, that's all it's going to do. I'm happy that I'm going to make this static. So firstly, we want some values. We want to know where we're going to write this data. So we'll do a private static read-only string, and we'll call this one parent folder. This one I'm just going to make in the environment. We will do get folder, get folder path. And then we can use special folders. I'm probably going to use common app data, which will be C drive program data on Windows. I like that one versus the user data. It gets too embedded. The only difference is if you're using multiple users on a single computer, this will be the same folder. That's the only thing you have to think about. So it's whether you want the same folder or if you want a custom one per user, you'd have to use a different folder. So you can use local app data, which would be then local to the user. So it really depends on preference, but for now, I'm just going to make mine the common program data or common application data as it's called here. And then instead of just being inside that, we want to do path.combine, or we're going to have to do the full namespace because Avalonia has one for path. So system.io.path.combine, there we go. And then we have environment variable, common, and then we'll have a folder now called batch process 3. So this is going to be the parent folder we're going to store the data in. And then we want the same again. Private static read-only string, and we'll call this one crash file path. And we're just going to have one crash for now. Once the application bombs out, there's never going to be a second crash, so will be a single crash file for now. This is literally designed for an unexpected crash. It's going to be system.io.path.combine, the parent folder, and we'll call this one lastcrash.json. So with that, we want a way to write an exception. So we'll have now a public static void set crash data. It'll pass in an exception. And now this is something we can invoke, and we want to write a file. So the first thing we want to do is make sure this folder exists, so the parent folder. So for that, I just do directory.create directory, and if it already exists, it does nothing. If it doesn't, it'll create it. This could crash, but at the point of doing this, what are we going to do if it crashes? This is the crash handler. So there's not much we could do if this crashed, other than report to the user with a message box potentially. So I suppose we could always bubble that further up and do a try on here. And then move this into here. And the only problem is the caller that is going to expect a problem is not going to be aware of the problem because we're not going to bounce it back up. We're just going to handle it here. So this is really a last resort problem that we don't care too much about. So we're not going to rethrow. We're just going to see if we have any kind of message box on Avalonia. And I bet we even don't have that. And no, Avalonia doesn't have any system message boxes for now. So to be honest, what I'm going to do in here is just simply say to do handle system message box or other way to inform user of crash. So that really is a stuff's gone really wrong and our application needs to be looked at kind of message. We'll just leave that there for now. So back in here, we've created a directory. And then all we want to do now is write a JSON file. So again, this is nice and easy with modern coding. You can just do file.write all text. And then in the all text, we can just pass in the crash file path. And for the string, we're just going to use JSON serializer. And we're just going to serialize. And then we're going to pass in a new crash data. This is the class we just made to store the crash data. And then in here now, we can do crash data equals UTC datetime now. Error message equals ex.message. Stack trace equals ex.stack trace. And source. We don't really know what we want for source yet. I kind of want the function name. So let's just put a breakpoint here and look at that. And then to be honest, that's this function done. We're just going to write the file. That's the job of the file. So let's now invoke that. So we'll do crash service. And because this is completely static, we just call straight into it. Pass in the error message. And then this will be restart application. Now if we force a crash, we get to here. So we have the date time is now. The message is the print settings can't be deleted. That's the message we passed up. The stack trace will be the full stack trace. Now, some people say don't ever expose the stack trace to the user. I'm one of them people that don't care. It can be reverse engineered nice and easy. C# code is so easily decompiled that if you're really concerned about showing these kind of bits of information, then I think you're focusing in the wrong area of importance, to be honest. And this is really useful for developers. So completely preference. If you don't want to expose your code like this to the end user, feel free to change this, but I like to expose the stack trace for easy viewing. And now what we need to look at is what can we pass in as the source. So I kind of want that calling method name. So this here, see this void delete print settings, that's what I want to see. And it'll be in the stack trace. So if we looked at the stack trace, oh, it's not showing me properly. The stack trace here, it's the first line, it says at here. But it's just nice to separate it so we can show it off at a glance. So I think what we want is the, where was it? Target site. So if we do a target site to string, that'll probably be what we want. So we have, what did we call it? Source. Yeah, source equals ex.target site. Dot to string. And now what's this complaint about? Possible null. So now we have the exception. Let's see if it writes to the folder and where we expect it to be. So we now go to actions, delete, cause a crash, and then the application will restart. So it spins back up. And now if we go to program data in C drive, do we have a batch process? There we go, batch process 3, last crash. And there's the last crash info. So we can see it nice and easily. We have a crash date. We have the source, which is a nice simple thing. We have a short error message. And then we have the full stack trace. So that's what we want. And then what we want to now do is when we start up, we want to look for this crash data and display it to the user. So for that, we'll go to main view model and we need to decide where we want to show this. And to be honest, I don't think we need to do it in main view model. I think we can do it in the application. So if we change the main view, it won't matter because we did it here, you see. So originally we were showing up the example here. So why not just place it here? Now this could be irrelevant of type of desktop at the minute. I know it only supports one, but if we ever supported it in the future, it would belong here, not inside of here. So all it means is if we ran this at the minute on a mobile, this would come in and get special folders like this, and we don't know what would happen on a mobile device, for example, or a single platform view like a browser. But I'm going to put it where it should be, and we can deal with that if we ever then expand it to non-desktop services in future. So what we want to do is get the last crash, and that will be the crash service, and we need to now one that says get crash data. So get crash data, create the method. This will be a crash data, and it's nullable because we might not have any crash data. And then in here, we want to try to get the crash data. We don't want to throw if it fails. And then here we'll just do a one-liner. So if anything fails, we just crash. So we want to return a JSON serializer.deserialize, crash data, and then file.read all text. and the crash path. So this would crash if the file didn't exist, which you can at least protect against that, I guess. So if not file dot, or rather if file exists, not. If file exists, crash file path, then try to return the deserialized, otherwise return null. Or what we could do is just have a complete fall through and just return null here. So it passes through for any reason we get to there. Now if it crashes, then we're just going to make the presumption that the crash data is bad and the JSON's failed. So we can do another check. If the file exists, then we want to delete the file because we're going to presume it's a bad format. Something's gone corrupt with the file. And we might make that a helper function called clear crash data because we might want to reuse that. So we'll call that clear crash data. And then in here, same again, try catch exception, don't rethrow. And we'll just do if file.exists, the crash data, file.delete. This is ignored for now. There's not much we want to do on failure. And this will then attempt to clear crash data. Because both of these are try catches inside, we shouldn't ever crash on these. And there's not much we can do at the minute anyway if they did crash. So I think that will correctly then deserialize the JSON file and delete it if things go wrong. So we should be able to now do a simple check that if last crash was something, so if it doesn't equal to null, we have an error. So if we crashed the last time, get last crash data. We now want to do that new error window with a data context of new error view model. Then we fill this in with info, and then we just show the window. So this should automatically crash and show the window. And then if we set now the title can be the last crash dot short message. What did we call that one? Error message. So the title's the error message, and we only have a description really. So what we'll do is a new string in here, and we'll say batch process crashed at, and then in here put that source, last crash. And then we can do return new line with the following error. And then we'll do, I guess, return new line again. And then the error, which is last crash dot error message. Why do I feel like we've used that again? Yeah, we've used it in the title, but we'll reuse it here. Full stop. Return new line. Probably do 2 there. And then we'll say stack trace, return new line, and last crash.stack. And let's see what that looks like. And that's opened straight up and showed us this print setting cannot be deleted. Batch process crashed at and the place it crashed at with the following error message. And I think we would probably want a new line between that. I think it just looks nicer. And then it shows us the error message. So now we could have the user copy and paste this. We could email it. We could have an auto-generated thing. That doesn't matter. But at the minute, we don't delete the file. So if we restart the application, it's going to just keep reshowing this crash data, even though we've dealt with it. So that's just going to pop up and keep reshowing this. So what we need to do is delete that file. We have the crash service with clear crash data, so we need to call this. But what we have to think about here is if there's a crash, say, in, I don't know where, some early starting point that's repetitive. So as soon as the application starts up and we get to main view model and there's a crash in main view model, and I don't want to do this because it's going to recursively start up, but say there's a crash in the main view model inside of the constructor and we do something here and we throw an error, or the database crashes, which it could do, which we probably need to protect against this because you could have, well, to be honest, that should be an unexpected crash. It should bubble up. But the point would be, if it's going to crash and bubble up and instantly restart, so if this was going to crash and restart, we need to really give the user time that if it's stuck in a loop and it crashes, opens, give a delay, like 10 seconds or something. so that if it crashed and reopened, and then the user, after 10 seconds, realized it crashed again, or if it crashes immediately, you don't want to keep re-showing the error message, if that makes sense. So we have to think about that. So a way we could do that is this part here is the thing that could cause constant recycling and reopening. We want to probably check here before we reopen when the last crash was before we write the next crash. So what we want to do here is say get previous crash data, if any. So we'll say for last crash equals crash service.get crash data. And then we can now write the new one. We've already got the old one, so this will override it. And then before we restart the application, we want to check if we previously crashed in under 10 seconds, don't reopen, basically. So that would mean if there was an infinite crash, or even if we forced a crash within 10 seconds of the last crash, we'll stop this recursive reopening behavior, and it's up to the user to restart the application manually. That should protect us from any kind of constant crashing, and we'll test if that works once we've written the code. So we can say if last crash dot crash date, and this is dependent on obviously the machine's date being right, which it should be, and you want it to be greater than the date time offset dot UTC now minus time span dot from seconds 10. So that would mean basically if the crash data indicates that it crashed within the last 10 seconds, then this would run, whereas we want it to be the opposite. So we only want it to run if it's less than that time. Oh yeah, and we didn't check if that was null. So now we only restart if we crashed later than 10 seconds apart. So let's just first check if, oh, we also need to delete the crash log once it's shown. We forgot to do that. So once we show the error, we can then delete the error here. So that will just be crash service.clear. So as soon as we've displayed the error to the user, we delete the error. But again, if you bear in mind, if we did this, showed it straight away, deleted it in less than that 10 seconds, then we're going to bypass this straight away. So let's put the same logic here. Just do task.delay 10 seconds, and then continue with and then we can do crash service.clear. So we won't auto clear the log for at least 10 seconds. Now we could move this out and say have this logic next to the other logic in the program. So when it starts up in a crash, you could handle it somewhere like say here after it starts. But to be honest, this is fine here. So don't delete error log for 10 seconds. So this is going to ensure that we have to have an application that runs for at least 10 seconds before it wipes the old log out. So even if you showed the error log, closed it, and reopened the application fast, it would still re-show the data. That's a side effect. But it's going to prevent any rapid crash and reopens, if that all makes sense now. So let's test this out. What we should do is we should see the error message this time. So we see it here. And then if we watch this, it's been about 10 seconds now. There you go, the file's just been deleted. So we then close this and reopen. We shouldn't see that error message pop up again. So you can see now, no error message has popped up and no error file exists. So now the key is if we crash rapidly, and we can do this manually just in case for now, what we can do is delete this, let it crash. When it reopens, I'm going to instantly crash it again. Oh, and that didn't reopen. And that's because the logic is flawed at the minute. I think the null check will fail and it won't happen because it's null. So I think I've just done my null checking logic backwards. Yeah, so that is slightly wrong logic. It wants to be if last crash equals null or last crash. That's what we should have done. So let's try that again. So now we'll open up, let it crash, and cause a crash within 10 seconds. So this is opened up and shown the crash data, which is the last one. So we need to cause a new crash. Let it restart, which it has. And now quickly cause another crash with under 10 seconds. And then the application hasn't restarted. So that logic's working correct. and the last crash is still there. So the rapid second crash I caused is still showing the crash file. And you can see there's the crash that happened the second time. But we didn't automatically restart the application. So now when we manually start it up, it's still going to show that previous crash. And there we go, perfect. So we have an automatic restart to display the crash. But if a crash happens within 10 seconds of the last one, that automatic behavior just stops. And then at least now the user's in control. If something crashes, reopens, then it's not going to force the application to keep restarting. I think one last thing I noticed, I don't think that text box is wrapping, which will be in view models, not view models, views, error view. And if we just cause this to crash so I can actually see it, yeah, you can see this is actually going off. So I want to just wrap that text. That will be the error view, text box, and text wrapping, wrap. Cause a crash again. And there we go, the string's nicely wrapped now. So we can see fully expanded, and then the string wraps. So I think that's it. I think we now have a nice error catch system. And then the only thing you need to be aware of is, I think everything that's an unexpected crash should just bubble up and crash. You shouldn't have to be trying to catch things in certain parts of your application and then handle what happens in an unexpected situation everywhere. I think you're best just letting it bubble up and deal with it. But if there's places where you can recover, so say you make a new settings and you click save and this crashes and it's unexpected, you should be able to just handle this part, and instead of crashing the whole application, you kind of understand that something went wrong with that specific event, and you handle the crash there and show the window. So we'll probably do that next to show a sort of expected crash behavior in one way. So there's the handling of expected crashes in a way, which will make use of this crash service as well. But we now have the main top level catch all crash system that seems to be working good.